Today's session, this session is about continuous deployment. What we're going to do is look at it from three perspectives. There's sort of 10,000 feet, where we've got Professor Laurie Williams, and she's been working with multiple companies, and she's been running a summit which we'll talk about. So it's actually across industry on how they apply these methods and the problems they have. We're also going to have a talk by Bing, by chap Alex, and Bing is the sort of classic continuous deployment type product where you've got a service with very little on-prem. So that's like the 1,000-foot perspective. And then finally we have Office, which is probably the most difficult thing to deploy. And Jen Beckman was going to give a talk on that. And since it's sort of three talks on very similar subject, then instead of taking questions from each of the speakers, what we're going to do is we'll take no questions during each speakers, and then right at the end, we'll have all three speakers up, and then we can ask questions from the same thing. Because you'd probably be asking roughly the same question from each of the same speakers, so it's a lot easier just to have them all up and speaking. So first off, we have Professor Williams to talk about challenges in continuous deployment.
Thanks, Brendan. Thanks all for coming to this session. Since you came to a continuous deployment session, you probably know what it is. But I'm going to start out just by defining it, just in case. And so this is a pipeline. And with continuous deployment, when a developer makes a change, it goes through a number of automated checks, starting with unit tests, could be code review, there could be a number of different checks that are supposed to be happening without any human intervention. And so it goes from a developer to actual customers, no human intervention. And it happens in some companies a matter of minutes. Like some companies they deploy hundreds or even thousands of times a day. And some it's less often. The point is to get feedback back to the developers as quickly as possible. But from a definition standpoint, continuous deployment says no human intervention. Related, continuous delivery is similar, except there are some manual checks along the way. And so I kind of randomly put some manual steps in here. It could be at any point, but continuous delivery says you haven't yet achieved continuous deployment. From another term standpoint, you may hear also DevOps a lot. And DevOps is an organizational structure where the operations people who do the deployment collaborate much more closely with the developers. And so I'd say DevOps is an organizational structure that would go around or could go around both continuous deployment and continuous delivery. Brendan mentioned that I've been running what I call the Continuous Deployment Summit in Silicon Valley over the last 4 years. And on this slide are 17 companies that have participated in the summit. In the 4 years, they could have participated 1, 2, 3, or 4 times. If you look at the companies, a lot of them you'll know. Some of them you won't. But we intentionally choose companies for the summit that cross the spectrum of large company to small company, from companies that I would say were born doing continuous delivery and continuous deployment, like Facebook, Netflix, Google. They never did anything but that, although they still have challenges, to companies that, like as Brendan mentioned, there's Windows, it's a large monolithic product, and Bing in the same company, again, a spectrum. And we have companies like Cisco, IBM, again, and SAS that have large monolithic products. The uniting factor of all the companies is that they all want to use continuous deployment types of practices to improve their efficiency, to get value to the customers quicker, and to get feedback back to the developers. They all have struggles. Even the ones, like I said, Facebook, Google, Netflix, that started that way, they still have struggles. They still want to be more efficient. As far as the years, the first year was in Facebook, second year Google, third year Netflix, and Brendan hosted at Microsoft just this past Monday. So I couldn't do my slides ahead of time because it just happened. And so what I'll be sharing with you are the challenges that the companies talked about in the Continuous Deployment Summit. It's not just about challenges, though. There actually are some benefits. So I'll start out with the benefits and then spend most of the time on the challenges. So the companies that use these practices, some of the benefits, first of all, relate to the engineers. So the engineers are happier. They get feedback quicker. They feel more empowered. And generally they like working that way, although we'll talk about culture in a little bit. The company gets a lot of value because they're continuously sending value out to the customers, giving them new functionality on a regular cadence. They don't have, big release stress because the releases are happening all the time. If a function doesn't make this release, it can make the one this afternoon. And so you don't have that type of release stress. The companies themselves, the attendees, said that they feel they have quality and productivity benefits, although we don't have empirical evidence of that, but that's the way they felt. That the focus on automation towards getting to, the continuous deployment, that automation, they view it as a benefit, the focus on automating more and more of the practices. Quicker mean time to repair. So if there is a problem, the ability to get a fix to a customer quick is a benefit. So they have this deployment pipeline where they're continuously getting change out. And so if there's a problem, they just follow the normal process and get the change out. To me, one of the biggest differences that you can see with that is it was 2014, so it was a while ago. There were security problems found both with Jeeps and with Tesla within 2 weeks of each other. So for the Jeep, when there was a security problem, Chrysler sent USB sticks out to all the customers, all the car owners. 1.4 million USB sticks went to car owners. What do you think happened to those USB sticks? Right? How many of them actually were used? How many of them were thrown away? How many of them were repurposed? Within that same time frame, a couple of weeks later, Tesla had a different problem, but a security problem. They fixed it over the air. So they have the ability to do something like that. And any of the companies that have this continuous deployment pipeline have the ability to get fixes out quickly. And then, in general, developers get feedback. So those are the benefits. Now we'll talk about the challenges for companies. The first challenge is, what happens when you have a large change? So part of continuous deployment includes continuous integration. So when a developer makes a change, they are always integrating. They're not keeping things on their own machine, on a sandbox, on a different branch. They're actually integrating the change into the main branch. And so what happens when you have a big change? Well, generally what is done is a feature toggle is put around that change so that the developer can continue to integrate their changes without the customer experience changing, and they can keep developing that way. So I have architecture changes, any large feature changes, database changes are all done this way. And what this picture is really showing is, and this is a little bit of classic with the database schema change, that what can be happening is you're using one database, and then when you make a change that has a schema change, then you put a feature flag around it, and potentially what's happening is now that for testing purposes, you're sending it to both the paths at the same time. The database, that both databases are being populated, and then when you feel good about it, then you take the old database away. And that's similar to any kind of large architectural change as well. You can be having potentially traffic going to the new architecture. You're testing the new architecture, but the users can't see it yet. And so it is a testing strategy where you're testing in production, which we'll talk about more as well. But this is really enabled by the use of feature toggles and the way that you direct the traffic. Another challenge and a perception is if you're making all these changes so quickly, what happens to privacy and security? And a couple things to say about that. First is organizational. The organizational is really on this slide. So in many organizations, those security people, they're in a separate group, and they're not integrated. Another strategy is Sec DevOps, where now it's not just DevOps, but the security people are in there as part of the team as well, tightly integrated. So one, from an observational standpoint, you would think these continuous deployment companies might be on the leader of the DevSecOps movement, but really not so. There's not a lot of evidence of them having security integrated as tightly. And so if you take it from a representative standpoint, probably DevSecOps is more of an idea at this point than really implemented in a lot of companies. One change that we've seen over the 4 years of the summit is that the security people are being more integrated, that they are being more partnered with, as opposed to as early in the years, it was more like those security people, they just stop our releases. And now there's more of a partnership that's taking place. So, and that may be representative of companies as a whole, as security is being more of a consultant, more of a partner, and not just stopping releases. So that's an organizational standpoint. The way that the companies deal with security and privacy changes, or some of them anyway, is if a change has a security or privacy implication, that again, they put a feature toggle around that change, and it is not visible to the public until the security or privacy people look at that change and okay it, and then they release the flag. So that's the way that they, in general, control that. Another thing that I would say some of the more advanced companies, including Bing and Windows, as you'll see, do feature experimentation. So feature experimentation is where the company are putting out potentially multiple versions of the same thing, or trying a new feature and trying to get data that would say whether the customers they like the change or not. So this is a Netflix screen, and Netflix is a big company that does feature experimentation. It's possible that if you and I sat down with our laptops and pulled up Netflix at this minute, our screens would be different, because they're continuously trying new things out. And they're watching where we hover, how long we stay, and all kinds of things about what we do. And then they can keep a change or not keep a change. So in a lean startup, pivot or persevere, they're collecting data, instrumenting code, collecting data, making decisions. Sounds good, but it's more complicated. And so some of the complications, back in the early days of the summit, we actually wrote an IEEE software paper, and one of the adages we put in the paper was every feature is an experiment. And that's kind of the idealistic view. Now it's like, well, maybe not every feature is an experiment, because there's just the cost of instrumenting code and collecting all the data, which could be every change might have 1,000 different metrics. And then the use of guardrail metrics is what Microsoft calls it, where if there's something that hits either the high or low to say some big change has taken place, then you have to get alarmed to think of what has that change done, and take it out. And the experiment, even for companies large like Google or Netflix that have many, many customers, they can't just run it to get a good enough sample size, because we behave differently in the morning than we do at night. We behave differently on a Monday than we do on a Sunday. And so they have to have longer periods of time where they're testing these features out. So in general, experimentation is more complicated than it was originally thought about. So with all that, the experimentation has feature toggles, architecture, database changes have feature toggles, security has feature toggles. There's other types of feature toggles. And the companies kind of do admit that when they have these experiments, if it's a failed experiment, say, no, don't make that change, they might just take that code and turn the flag off and leave the code there. And so now it's dead code, if you will, that's hanging around. And so just all of the code that is hidden behind feature toggles can remain there, causing technical debt. And so that, you can have a movement underway, potentially to identify this area of the code that have this dead code, essentially, and try to remove it. It can cause a problem because someone might see some code there and say, I like that code, but because it's behind a feature toggle, they're not sure if they can depend on that code or not depend upon that code. So in general, the complexity that's added with all of these feature toggles, the complexity and technical debt, needs to be considered. So radically different types of testing. So as I mentioned earlier, unit testing is done much more often, which is a good thing. But other testing strategies, so testing strategies would say that you put this code out in production behind a feature flag, and you test it through the APIs. So like when I think about what we teach students at a university, we're not teaching them about doing something like that. We're not teaching them about deploy your code and then test it in production. A lot of some companies say they have to test in production because they need that level of scale. They need it to be on production servers to make sure that it's working properly. So deploy it out there through a dark launch, so that users can't see it, and test it that way. But then the next level of testing is as you're deploying the changes. So continuous deployment companies typically may dog food a change, so it's only visible to own employees. And then when that works, then deploy it to 0.5% of the population, 1% of the population, 5% of the population. You're watching to see how it reacts, which that's a form of testing in production. You're looking at the types of changes and defects and pulling back potentially or rolling a new version out quickly to take care of a change. Mobile deployment is definitely a challenge. So they can even say web development, we got that one. But mobile deployment is harder. The Play stores, they do not allow you to continuously deploy changes. A company may only be able to make a new version once a week. And so you can't have the same type of strategy. So they have to be more careful with their quality for their mobile deployment. Also, they have to consider that on mobile devices, you may take a version and you may never take another version. And so there can be, an infinite amount of different versions out on the customers. I mean, they even talked about, TVs, that it would be cheaper, like Netflix says, it would be cheaper for us to buy all the TVs back with some of the versions on them than to maintain those versions. And so there was a change in this year where people are talking about apps being built with a much thinner client and more JavaScript, more code that, so that what's on the phone or on the mobile device itself is smaller and everything else being on a JavaScript or on a server, and the feature flags being able to be changed so that you don't actually have to deploy a new version on the phone or on the mobile device. You just change the feature flags centrally in order to take care of some of these concerns. And then the last one is tool investment. So there's a lot of focus on tools, open source tools to control the deployment pipeline. There's Chaos Monkey tool where companies, particularly Netflix, are injecting instability into the network to see what would happen. And the companies share these types of tools, but yet all of the companies have large IT organizations as well in order to support continuous deployment. The whole pipeline, the automated unit tests, automated static analysis, any kind of fuzzing, those are tools. I mean, from a research standpoint, the companies are really looking for good tools and management of false positive, that type of thing, so they can put it in the tool chain and not need human intervention. So from a research standpoint, there's a lot of need there. Oh, and then the last one, culture shift. Culture shift in that now the developers are the ones that are typically called when a problem surfaces, where before it used to be like those support people handle the field problems. Now it's usually, I integrated something today, it caused a problem, I need to deal with it. Which means the developers seem to be much more cognizant of their quality and putting out high quality products, which is a good thing. But on the other hand, it adds another level of stress they didn't used to have, which is not always a good thing. And then just in general, the new types of development that happens with continuous deployment, it just causes a huge culture change, which not all of the people say it's, they actually say it's the toughest thing of all, is the big culture change because of all of the different things that the developers have to do that they didn't used to do. And they talked about having like shows where they go from location to location, talking to the development teams, sending someone with a success story to another location. VMware, they talked about going from, in this journey, going from multiple branches to one branch. And so they killed the branches, and they had some like ceremony where they had cupcakes with coffins on them and brought them to all the locations to, for a ceremony for killing the branches. to make lighthearted of it. But they say the culture changes are actually quite hard. To summarize, lots of changes. You know, in a way, it's like change is everything. But there's a lot of opportunity in those changes along with the challenges. Okay?
So one of the things in the summit is that most of the people have very similar problems because it's sort of like difficult. Yeah, when you have large software, it's just difficult to change it with so many different people. So, but as I sort of say, is having that range of different types of product types is quite useful to learn how effective CD is and how ineffective it is at certain times. So Bing has a different perspective on this. Chap, do you want to?
Hello, everybody. So I'm from Bing. We're going to be talking specifically about Bing UX. So if you've ever gone to Bing, thank you for your support. Everything you see is built on top of the platform that we're going to discuss a little bit here today. So some of the Bing core-wide, or some of the core Bing-wide principles. Lifesite quality is paramount. You know, our brand is the quality, right? If we have bad quality, people will go elsewhere. We're second place in a difficult race. So everything we do has to be high quality. We always are looking to innovate and produce new things. And again, it's a competition, right? And we need to make sure that we're keeping pace. We need to find differentiators that draw people toward us. Data rules. So some of the things that Laurie was just talking about, you're going to see echoes of it. It's really cool, actually. Yeah. Data is what we use. We can't use emotion because if we're automating everything, there's no emotion, right? So we have to make sure that we pay attention to the data, and we have to believe the data, and we have to use the data. And search is an expensive business. It's complicated. It's very expensive to run. And so everything that we can do to improve it, to make things a little bit better, a little bit faster, a little bit more automated is what we go for. So here's a high level of the Bing serving stack. It's a multi-tier stack. They are hosted in servers, geo-distributed around the world. And each tier is on its own deployment cadence as well as their own code base. We handle ingress, routing, and throttling, and then the UX rendering tier, data query and aggregation, and then the various data-based indexes at the bottom. And a vertical along that side is metrics and monitoring. We're talking today about the UX data presentation tier. We have many hundreds of developers in this single branch. We are seeing exponential growth over the last 5 to 7 years, precisely because of the success we've had with improving agility and continuous integration and continuous delivery. The UX data and presentation tier at Bing is less than 100 milliseconds at the 95th overall. And we render all of the HTML. We handle the API entry points. We handle Cortana. We handle Yahoo. There's other deals with Yahoo and Apple. And so we cover a large space. It's a very large monolith. So why did we invest in agility? And this is sort of what I was just talking about. We need to stay competitive, right? It's a question of survival. If we can't keep pace, if we can't differentiate and innovate faster than our opponent, then we're going to continue to fall by the wayside. People will just abandon us, right? So I want to keep my job. I need to support my children. So let's try to do what we can. We need to make sure that we are able to capture more market share. We run a lot of experiments, and this is another thing Lori was talking about, the emphasis on experimentation. We run a lot of experiments, thousands of them per month. Each tier that you saw in the previous slides is capable of running their own experiments. And so there's a lot of things going on in the Bing stack every day. So the question then becomes, how can we run more experiments? We need to see a dramatic increase in developer productivity. We need to figure out a way to make sure that they are in front of their desk, getting stuff done, fingers on the keyboard, making commits. We need a dramatic increase in the number of developers as well. If we've only got 5 people working on Bing, we're not going to see a high pace of innovation. So we need to get more people working on it. And finally, we need to see a dramatic increase in experimentation. So we need to make sure that these features, these experiments that they're doing are easily done, easily created, easily implemented, easily experiment on, seen in production, and then the data analysis needs to be simple as well. Okay, so let's fast forward 5 years. What was the impact? What was the impact of agility, specifically the Bing UX agility? We saw a dramatic increase in the quality of the live site, and this is something that Lori was saying as well. It was almost overnight. So we were previously doing monthly releases, which really amounted to like every 4 to 6 weeks. We wanted it to be every 4 weeks, but what would happen is we would deploy to the live site. There'd be a bunch of things broken on the live site. We'd spend the next week or 2 weeks hot fixing them, and so we always see this delay. When we switched over to agility, it was really impressive. We went from 6 or more live site incidents per month to less than 1 on average. We saw that there was an impact on engineering as well. The developers are much more satisfied. They can see more quickly the result of their work, right? It's no longer an asynchronous thing where they check in something on day 1, it goes out on day 30. For us, they check in on something on day 1, and we sometimes even get it out on day 1, but at the worst, we'll get it out on day 2, and so they have a very quick feedback loop. Our pipeline has also been able to scale to meet this new demand. We've actually done a lot of optimizations to continue to support that based on capacity and resourcing issues that we had. We also see an impact on the code base because the developers now are able to get things done more quickly. We see much more smaller code reviews. If you're reviewing less code, you're able to do a better job. If there's fewer files to look at and fewer changes in each one, you get a much better overall code review than you would for larger changes. They're also shorter and more focused. And last but not least, we've empowered everyone, and Laura was talking about culture as well. We empower everyone to reject a code review that doesn't have tests, because the tests are what we live and die on for agility. This is something Laura was saying over and over. It's the tests that make the difference. So here's some of the pre-agility metrics. This would be from roughly 2011 or 12. We had roughly 80 engineers in our code base. Some of the more interesting things, we had 5 different development repos, 1 main repo and a separate release repo. So you can imagine the reverse integrations and the forward integrations we'd have to do every month, and it would be a huge delay to try to get that stuff sorted out. We were able to ship once per month. We had roughly 3,000 tests, 80% of which would pass, and they were run ad hoc. So what I've said in the past is we had some tests, some of which run. Of those tests that ran, some of them passed, and there was just a giant question mark for everything else. In terms of the test pass that we were able to do, remember I'm talking about the Bing UX, we had less than 3 browsers. It was whatever the developer had on their machine, if they wanted to do any browser-based testing at all. We handled the Bing web results, and we would see roughly 10 experiments per month. Now think about, it's like it was a choose-your-own adventure. If you wanted to do effective experimentation at Bing at that time, you'd have to say, okay, I'm going to try this experiment where I change the link color to purple. And if that one works, I think I'm going to try to underline it. But if that one doesn't work, I think I'm going to try to bold it. And if the bold one doesn't work, I think I'm going to try to do this and that. And they would have to do all of that coding ahead of time because we only shipped once a month. They'd have that one shot, they'd get their code in, and then they could experiment. And so they always had to do much more work than they needed. So that's why we saw so few experiments. So here we are today. Here we are about when I wrote this deck. It's 46 now. We've seen over a tenfold increase in the number of developers working our branch. And it's basically because, like I said, they've seen the success. They've all onboarded to our repo. And so there's one repo that everyone is working in. We see 15-minute builds. We see 5-minute start times. And it's 10 minutes to test now. It was 20. We met our goal finally. We have one Git repo. It's a mono repo. Everyone's checking into it. We deliver code 14 times a week. In fact, last week it was 17 times. We have 46,000 tests now. We have 4 nines in a test pass and auto execution. We have 14 browsers, 34 devices. So you see that we've been able to get things done and scale them well so that we are continuing to improve things. Looking at the inner and outer loops, the continuous integration, continuous delivery, both highly integrated with Visual Studio, In fact, my goal is to completely integrate with Visual Studio so that they have one screen that they look at all day. Right now, there's still some variation. Build and test, deploy to staging, and we ship gated by 100% pass rate. We test everything up front. All those 46,000 tests are run at code review time, and if any test fails, they don't get checked in. Our stage deployments, and you were talking about staging as well, we deploy to a canary environment first, scale unit by scale unit. If that passes, then we deliver the rest in parallel. So one of the things that we've learned is that we just break stuff. We broke Visual Studio for a while. They've broken us multiple times. What's nice, though, is that our scale actually determines whether other partners can scale or not. But in doing so, it helps to improve them, and in them improving, it helps to improve us. So we have a really good relationship with our engineering excellence team, really good relationship with the Visual Studio team services team, and any of the other partners that we work with. We improve everything that we can. My team is not afraid to jump organizational boundaries or jump to another repo to make a change, to improve it, because we know that that change improves it for everybody else. And they're fully empowered to do whatever they need. We know also that scale magnifies improvements and regressions. A great example of that is we run 70% of our tests on a browser. So the test starts and says, start up this browser, waits for the browser to start up, and then runs the test. That's inefficient, right? If it takes 4 seconds to start the browser and we have 46,000 tests, then we've wasted minutes of time. So what we've done is we pre-warm the browsers. We have the browsers already running, and the test grabs the next one and runs it, right? So we just find that we can continue to improve just because we want to get faster. And we play well with others. We have also got something coming up with .NET for .NET Core that's going to be really exciting. So we decided, and we learned that if you have fewer moving parts, again, this is some I've always been saying, if you have fewer moving parts, less things can break, you have much better standardization, and things run much more smoothly. We have one environment to monitor, that's production. Even our test environment is production, just doesn't take traffic. And we say that there's one validation gate. So like I said, if you are trying to check in, we're going to run all the tests. If any one of them fails, you're not checking in until you fix it. And all of our tests are co-located, meaning that they're right there. So there's the production code and the test code right next to it. There's no separate repo where we store test definitions or test results. Everything is strictly defined in our code base. Yes, so how can we optimize continuous integration? We took every optimization we possibly could. We did that over and over and over. Everything that we could find that would improve, even by a minute, our test pass or build times, is an improvement that it makes for these 900 developers who then see it every day and are able to move faster. That's the same as it was. Sorry about that. We also want to optimize the outer loop. So we have metrics that tell us how much time we're spending in each part of the outer loop so we know what we can improve. We're reusing the continuous integration mechanics. What you saw, the Visual Studio stuff, we're reusing Visual Studio for the outer loop as well to handle the deployments for us. We measure all aspects of continuous delivery. If you can't measure something, you can't decide whether you're improving. It's just bad, right? So metrics are super, super important. And finally, we remove humans. So like I said, automation, she said it over and over, automation. If you remove the humans, you will immediately improve because now you're forcing yourself to actually have operationalized system. Okay, so I think this is the last slide. I'm getting this signal. This is it, right? You implement, you measure, and then iterate. This is us over and over. This is experimentation. We believe in experimentation so much that we actually do it on our own code. All the code that I have, all the code that's been written is eventually going to become obsolete. We just assume that's the fact. And we're always looking to see what the next longest pole is. Oh, can we improve this? Well, this one's longer, and we go after it. It doesn't matter where it is, we just chase it. Loyalty is a myth. I gave this talk before, and people weren't happy with that. It was in a different country. But simple way of saying that, a better way of saying that maybe is, they'll go wherever it makes sense to go. There's no loyalty to the people in my branch. If they don't like what I'm doing, or if they don't like the system that I've built, they'll go elsewhere. It's not that hard. So we know that we're successful, and we aim to please those developers so that they stay in the branch. That helps us to design a system that works. And we have multiple feedback mechanisms as well. We have different ways that the developers can have their voice be heard. We regularly poll them and find out what is the most important thing to deal with next, and we chase that. Oddly enough, the most important thing to chase right now is documentation for us. Not even an engineering problem. Documentation is what the developers are least pleased with now. So we're making investments in that to improve it, and there's multiple different ways that we're trying to do it. The end. Thank you.
Yeah, so it's no coincidence that sort of everyone, there's be no coordination between Chap and Laurie, but the problems are exactly the same across most of the industry. I think it's quite funny you're talking about documentation. Irene did a talk, did a study, and somebody talked about doing software engineering is very similar to sort of cooking, and writing the software is basically the actual cooking itself, and documentation is the washing up. So that's basically it. So finally we have Office, and the sort of many different problems of Office. So Jen?
Right. I'm Jennifer Beckman, and I am Office Engineering Manager. I actually previously worked in Bing with Chap, and we drove that experimentation number up to thousands of experiments, so it was lots of fun over there. Now, I've moved to Office. I'm in the Office Fundamentals group, which is responsible for the build, the flighting and experimentation, telemetry, security, and performance pieces of Office. And you'll see in this talk that we are very far from Bing and the nice agility that they've driven over there, and that's what I'm excited about doing as I most recently moved to Office in December. But I've been working with Office for a while. So when I talk about Office, you might be wondering, well, what are you talking about in terms of Office? Is it SharePoint, or is it the clients? I'm talking about the rich clients, so Word, Excel, and PowerPoint. That's the group that I work in, and that's what I'll be talking about today. Exchange and the other services are a whole different story. They have a different story around continuous deployment. But I'm really talking about the apps that are on your desktop right now, what you most recently made your PowerPoint presentation in. That is what I'm talking about. How are we dealing with continuous deployment and delivery in Office? And I'm going to rewind us and put us back to 1990. That was when the first Office suite shipped together. Word, Excel, PowerPoint before that, 2 releases before that, shipped independently. And in 1990, they put them all together in a suite and sold them together as Office. That was 28 years ago. And we have shipped Office, or versions of Office, every 2 to 3 years since then for around 11 different releases. It's about one release every 3 years. We would, the ship cycle was product managers would get together, figure out what features should go in the product, developers develop it, and then we would release it internally to dog food, get feedback, bug fixes, and then externally to an audience called MVPs or insiders, which are outside of Microsoft, but they're our close collaborators. They would give us feedback. We would fix it, stabilize, and then release it in a process which we called RTM, release to media, CDs, disks. And so that's kind of how most of Microsoft shipped products over this time frame. And the first version of Office in 1990 shipped in both Windows and Mac. Mac and Windows were 2 different product units, 2 different sets of people, 2 different code bases, shipping independently throughout most of this time. The web version of of Office shipped in 2008. and the iPhone and Android version shipped in 2013. And we handle it all the same way at the time. Off of the mainline Windows branch, we'd fork the code, and then they would work really hard to make it work on the platform that was targeted. So that's where Office is coming from. That's where most of the code base was built. It's C++. It's a huge code base. I'll give you some numbers later. But in 2015, I pulled up the Microsoft earning report, and it kind of gives an indication of where Office was at the time. Windows XP had just expired its support. There was major declines in the PC business market, and Windows and Office were often sold together. So if Windows declined, Office declined, and that's what happened to Office. Windows declined, we saw the decline in earnings from Office, and also our customers were transitioning to O365, which is our subscription service. In October 2015, that's when we shipped Office 2016, sorry. And this is when we already knew these things were happening, and this is where we started to integrate some of the continuous deployment and delivery practices that we were just heard about. So not too long ago. So let me give you an idea of what Office has been doing and working on with Office 2016. I mentioned before that each one of the products were shipping out of a different code base, each independently forked, run by different teams. In Office 2016, ever since we shipped in 2015, we've been working on trying to get all of the code into one code base. It's not entirely true, but we're working on it. Most recently, Mac was integrated into the Windows code base. So Mac, Windows, both ship from the same code, and that was January of this year, first time that Mac shipped with Windows in January this year. So it's a really huge accomplishment. The team has been working on it for years, getting the code together in one place. In terms of shipping the product, like I talked about before, we would bundle all the features together and say, surprise, these are all your features. Now we're shipping Office 12 times a year instead of once every 3 years. And that's approximately every month. The features are behind flags at dark. They're not turned on for our users until they're ready. And they're out there exposed percentage-wise so that we can watch to make sure the quality is high enough before they get to everybody. Here's by the numbers. We're slightly bigger than Chap. I was looking at their numbers like, wow, we're quite big. So we have 4,000 developers. We check in one check-in or a check-in every 20 seconds or so. We have 1,000 check-ins a day. The code base is 500 million lines of code, not just code, but tests, test automation suites, language proofing is huge. Tools and engineering systems is also contributing a lot to that number there. The test suite runs about 20,000 jobs, tens of thousands of scenarios, and hundreds of thousands of different configurations every day to get it out to customers. So what is, oh, my build slide's not working. See, it's probably a reflection of a feature being exposed wrong. Okay. All right, so how do we get features out to customers? It's actually not a lot different than what I described before. We still have audiences. Dog food is an internal set of users within Microsoft. Microsoft gets the product, and it goes out to insiders, similar to our MVP audience that we had before, and then goes out to production. So those mechanics are relatively the same. What's different is that we're trying to ship every day. We're trying to ship a mainline build every day. Out to production, it's monthly. And this cadence and velocity is a lot faster than what we were able to do before. Also, we have feature toggles, which is brand new in Office 2016. So having dark code and then rolling it out and giving it to our customers within the build is brand new, and it's something that we've been doing a lot of in Office 2016. Just to make things more complicated, we also split our user base into different channels. So we have our monthly channel. It's mainly consumers. These people are your mom and dad and yourself maybe who've bought your PC at Costco and have Office on it. You'll get updates every month through the monthly consumer channel. The enterprises are a lot more risk averse, so they don't want to take the cutting edge stuff. They've never wanted to do that. So they take a build every 6 months internally, test it, and then they deploy that 6-month build within the organizations for stability reasons. We are doing a lot of investments in the enterprise in this space. I won't talk about it here too much, but giving the visibility to the enterprises of how well the build is doing within the organization is something we've been doing with Microsoft 365, it's called. It's Microsoft 365. If you look it up on the web, it's an interesting twist on continuous deployment. All right, so there's a lot of challenges with doing continuous deployment, like I just described, with Office. The code base itself is written in C++, and a lot of it is 28 years old. So the developers that are working on Office right now, a lot of them are younger than the code itself. So things that we take for granted, or Bing takes for granted, for example, are just not there in the code. Telemetry being one of them. Oftentimes when things break, we're not sure how bad it's broken because we just don't have the data to tell us. We don't have a fast build and release process. Our build takes about 5 hours, and they worked really hard to bring that down, and they did a great job doing that. To get a signed build that's tested takes 4 days, and then getting that build out saturated to all of our production audiences is about 30 days on the monthly channels. Test coverage is another issue with such an old code base. The previous incarnations of our organizations had test organization. Oftentimes manual tests were run. Our person sitting in their office would click through the product. It was never codified. And so some of the tests are just missing. And so we don't have as much confidence in the builds sometimes if changes were made in places that don't have that coverage. The DevOps pieces of continuous deployment that were talked about is also challenging in Office because as we build and deploy these releases, they are not in our data centers, so it's not a situation where we have a previous, current, and next build that's deployed. We have the hundreds of builds that we produced and maintain in all of the different platforms out there, sometimes with shared code across web, mobile, and Windows. And so as an engineer who's responsible for DevOps, it's really hard to be able to tell what version of the code was it and what could be really going wrong. So it's really challenging. A lot of the differences and challenges that we have in moving to continuous deployment and integration has to do with just historical organizational culture. The technologies that were used in each one of these different platforms, so web and Windows, have different telemetry stacks. They have different way of ingesting and spitting out telemetry, so you can't necessarily compare the two of them. And so we work through trying to standardize telemetry, trying to standardize the different metrics. So we'll have often conversations about how to get to one thing. The different platforms also have just different philosophies about what it means to close a build blocking bug, what it means to run unit tests. The Mac team has a great culture around unit tests. They force every build to go run all the unit tests and will fail deployment if any one unit test fails. Windows is so big and the unit tests are so flaky that they don't even want their unit tests to run. So the two different cultures, as it grew up over time, just grew up with different ways of handling situations. And we will run into this almost daily with just people in a room having different philosophies and having to work through those issues. Just to wrap up, we have a lot of market pressure to continually develop new functionality within Office. Some of the cool features around collaboration are coming, if you don't already have them right now. And it's really fun to be in Office and be able to deliver these things in this new world where we're trying to ship faster builds of the product. Within there, we are also investing in different ways of developing the Office experiences. Lori was talking about other products also having this challenge. We have this really old code base, C++. It's really expensive to develop a new feature in the core C++ environment and then deploy and get it out to our customers. So we're looking at different ways of developing within Office. Add-ins is a way that we are also tackling this problem. Add-ins are a third-party way of adding to Office. So third parties, even in Office 2015, they were able to add new functionality to Office. But it wasn't the first-class way that Office developed and deployed features. But we were looking at it as an avenue to getting features out there more quickly as a first-party or Microsoft developers' experience of adding to Office through add-ins. Add-ins are used, it's called the Agave framework. If you search on the web, you'll be able to find it. And it's JavaScript-based. So small packages are delivered to the client, run JavaScript locally. There's a huge effort there to have that as our next way of adding features to Office. And then we're doing more service-based experiences delivered to the clients. The more obvious one is the help. At the very top, there's a little light bulb, and you can ask a question. That's a service-based integration with client. We have integrations with Bing. And when we do service-based integrations, it's much easier because we're able to deploy a lot faster and go through the services delivery pipelines instead of dealing with the big, fat clients. So we're having a lot of fun making Office, optimizing what we do have, finding new ways of getting features out to customers. And those are some of our continuous deployment and delivery stories. So, thanks.
So we now do questions. You can question the speakers. Okay.
Does that work?
That's fine. I assume they.
Oh, thanks. Oh. Hey, great talks. Do I have to push anything? Oh, there we go. Great talks. One of the questions I had, have you guys heard of the Knight Group disaster with feature toggles where they had an old toggle turn on and lost $460 million in 45 minutes? So how do you deal with, when you're doing thousands of experiments, how do you make sure that, you know, this feature is running on this person's machine, like on this server, and this feature is running on that server, and they're not sending in corrupted data or doing something bad? How do you deal with the different combinations of feature toggles?
Is that my question?
Well, I think
yeah, so my team owns the feature toggle API for Office, and I have to say it's really hard. There is a ton of complexity around what is being tested in automation and who has what, and dog food, so it is a problem that we do deal with. My experience with Bing, when I was in Bing, was that, especially with experiments, having a control and a treatment, even if you plan to ship the feature, you're much more confident in the fact that it is the feature that's causing the problem, and then you focus on making the data faster. So all the signals around crashes especially, in Bing, we worked really hard to get it down to minutes for those really strong signals of something going wrong. And ideally in Office, we'll get there. Do you have something to add?
Yeah, I think Lori's presentation talked a little bit about it.
Yeah, I mean, but it is complex, and you have those guardrail metrics. Basically something's wrong, shut it off. So to try to prevent something like that. But I mean, I do think that we need to acknowledge the level of complexity that is being put into the code bases, which is not something that we traditionally have dealt with. And there are companies like Facebook at the summit said they plan that those feature toggles will stay there forever. They don't ever plan to take them away. So, the impact of that type of development and all of the companies who use, prevalently use feature toggles, which is a lot, it's a different way to develop. We should be teaching differently because of that.
There's we recognize it being that it's not even just an experiment by itself, but one experiment can have a side effect on another existing experiment. So one of the final gates to turning on an experiment in production is we will rerun all of the existing tests and force that experiment in addition to whatever experiments the tests we're actually testing, so you get that coverage. They'll know ahead of time if any tests fail. We expect them all to pass, right? So they'll know ahead of time if any tests fail. They can look at the results and decide whether it's a transient issue or it's a real problem. And that's we also do the flight shutdown. So there's a handful of business-specific, like critical metrics, like revenue, that we will know within a few minutes based on the control and the treatment, and it gets shut down. Like it's an instantaneous shutdown.
Gunther?
One of the fundamental problems in product development is that a lot of the functionality is never or almost never used. So that's not only Microsoft products, but one of the problems. And we have looked into research to study which functionality could be taken out. I wonder how the continuous deployment, continuous integration paradigm accommodates this idea. Is there any?
Yeah, dead code is a problem. If we're doing thousands of experiments per month,
and that includes elimination.
Dead code, yeah. I mean, we would say comfortably maybe 10% or less of those experiments are successful, but we try. It doesn't mean that when the flight gets turned off or the experiment finishes that they go and clean up the code. In fact, I've been doing work like myself to reclaim some of that, some of the the dead config, and to work with the partner teams to clean up their related code. It's a problem. It's a real problem. It's a long-term problem that just adds to our working set. It slows our requests down slightly, and death of 1,000 cuts. Now we're 10 milliseconds slower. Now we're 20 milliseconds slower.
Yeah, I think it's an exciting development to have things, updated 100 times in 100 milliseconds. On the other hand, is it really the direction to go to make it faster, 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 faster? I mean, to me, it looks sometimes it's very incremental changes, and we need a kind of, on the other hand, certainly a more global perspective on the product, right? Yeah. Wrong or true?
I mean, it'll be interesting in the long run what will happen for that functionality that was never used. I've seen Standish Group statistics on that same thing, and it's like 60% of the code the features are never used, and so hopefully with the experimentation, then that is discovered, and the mechanisms are in place to just shut it off. Where before that functionality was embedded in the product, and so you couldn't easily just shut it off. So, hopefully that will be the case. And as I mentioned, I guess you said something like 10% of the experiments are successes, and Netflix will say the same thing. And I think that you had a study in, was it Office that was 30%
No, it's
were?
Bing.
No, it's Bing.
Oh, Bing. Okay. So, there's an acknowledgement that a large percentage of the features that are developed are not deemed to be an improvement, and so then they are shut off, which would prevent the features that are never used. It doesn't prevent the technical debt.
Yes. Yeah. But you may have been asking a slightly different question. Were you saying that it's not always best to chase latency, that you may have to sacrifice some of it for feature richness?
Yeah, in a way, yeah. Yeah,
it's a real tension that I feel in my team, because owning the platform, I'm ultimately responsible for the response time of the server, but all the feature teams just want to get their features out the door, right? And so they're coding away, and it's a problem.
yeah, we cannot only be reactive, we need to be proactive to some extent.
Yeah, so there are, the flights run at a low percentage, so it doesn't always hit at our 95th. The egregious ones do, and we work with the partner teams to help improve their latency in those cases.
Yeah.
Kind of a slightly different angle on the same question. And this might be a little bit naive, but as you're using metrics and you're rapidly releasing new features, do you end up in like a local gradient descent where you're kind of improving whatever metrics you're trying to improve, you're getting a little bit better, and you find that you're sort of in this spot where you found a product that is optimizing what you want to optimize, but you can't kind of jump out of that minimum because any particular new feature that you add is going to make the experience worse before you can sort of get over the hump and make it better. Kind of the thing that prevents, it's kind of what causes disruptions to be so disruptive, because they're a totally new paradigm for whatever it is you're competing with. And it's hard to get out of that if you're doing sort of an incremental feature improvement along the way. That might be a naive kind of way of thinking about the product development, but it's something that I kind of wonder as I hear your presentations. As much as I think it's awesome to get like millisecond deployments on new features, it's awesome, but thanks.
I think there's just two different paradigms. We have to recognize that you're not going to get a disruption from incremental experiments. That's why we do rely on new products coming out that don't necessarily have to run these experiments because their user base is brand new. Like Teams, for example, the new product that's a Slack competitor, they started out without having very many customers. They do experiments now, but when they first started out, they weren't expected to do experiments. Their expectation was to add a new product to the ecosystem that grew a user base, and then they're expected to optimize the experience once they have the users to be able to do that. So I do think there's just different places where you apply the technologies in there.
Yeah, but I think the same technology, it's just used a different way. So that's where dark launches. So it's behind a feature flag. They can develop a brand new disruptive feature for a long period of time and be deploying and continuously integrating it, but hiding it completely. Facebook definitely talked about that. So like Facebook Live video or things like that. I mean, they did this continuous deployment, and then started to experiment, and then eventually when they were confident enough, released it to all of us. So it's the same technique to use for little changes and big changes.
That's the answer I would have given to dark launch.
So in Laurie's presentation, she talked briefly about chaos engineering. I was wondering, does Bing or Microsoft Office do any sorts of these kind of resilience testing in the field? If yes, have you done anything to kind of minimize the impact of the failure to those users?
Did you know what Chaos Monkey is?
Yeah.
Yes.
Okay.
Yes. Short answer, yes. We have multiple different layers. Like we do defense in depth, right? So we run all the tests that we can up front. We recognize that not everything's going to get tested. So there are separate systems. There's one that's continually fuzzing the live site and looking for issues. There's a pen testing team that goes and tries to penetrate or defeat one or more entry points on Bing. And there is a separate system as well that is periodically just taking one of our machines offline and seeing what happens as a result. Right? So there's many different things that we're doing to try to guarantee for the user that we have a consistent experience.
Okay.
Thanks. So I'm curious about how you got from a 90-minute build down to a 15-minute build. Was that, I guess this was for the Bing team, right? Was that primarily by migrating to a cloud-based build technology, or did you do some optimization elsewhere?
It was a combination of both. Okay. So there is an internal cloud build system. It's called Cloud Build.
Imagine that.
Because they figure it should be descriptive, right? That's their documentation, actually. It's just cloud build. That does, there's a certain amount of caching as well of previous targets, and they will pull in a cache. A version of that has been enabled for Dev Machine as well, because a Dev Machine doesn't have multiple build servers, right? But they will still use the remote cache and rebuild only the things that we need. But yeah, there were major changes in the way that the code is laid out in our system, and we have been consistently moving stuff out that the developers don't care about. In fact, there's even a flag for local build that doesn't build the test projects, so that they can get a faster build. But yeah, it's again, like with anything else that I say, it's going to be defense in depth. There's cloud build servers, there's local stuff. We've done a bunch of optimizations, dead code cleanup, yeah. It's an ongoing process.
So is there hope for the 5-hour office build?
Yes.
Hey.
But to be fair, a monolith that size, you're only going to get it down so far, right? This is where a remote build actually would help them more than it would us. Like in the initial days, Cloud Build was great for us, but now that we've minimized it as much as we can on a dev machine, the parallelized build servers isn't helping us that much, us.
Yeah. No. Oh, sorry. It's okay.
Yeah, this discussion of all the code behind the feature flags, it made me wonder about security. It seems like there's a different sort of surface area now for security text. You can change the value of a flag, and now you expose code that wasn't intended to be run. Has there been work in that space, or have you seen any real attacks in that space?
I understand what you're saying, and I have not heard of that, but I think it is a real threat. You just need to get to that API, right? Somehow, which is how testing in production often happens. They get into the API without going through a user interface. So the threat is there. I haven't heard any of attacks that way, though.
You're monitoring everything, though, so presumably you would see a flag that was on, and you're like, this is not ever supposed to be on. So there's a lot, I think, like related to the toggles, there's a lot of monitoring of them.
Right, yeah, and so when I talk about security, I talk about the instrumentation and the experimentation as a way to say, this is not right. Whatever's happening right now is not normal. And then you might shut something off to react, but it also helps from a security standpoint, yeah.
The security starts with making sure only certain people have the ability to set flags. Like, none of you are going to be able to go home and try to force a specific experiment or a feature for Bing or Office. It's just not the way it works. Like, we only allow that to happen within our own machines. It's controlled by IP. Now, we have a way from my office, sitting in my office, which is inside Microsoft's CorpNet, I could force myself onto an experiment, but it's only enabled for those people.
Hi, thanks. So this shift from no experimentation to virtually continuous experimentation that you are going through seems to suggest to me that you also need a shift in mindset of your engineers from sort of an engineering-centric mindset to a scientist-centric mindset, somebody that sort of thinks about experiments. Do you see that in your employees, and did your recruitment change to sort of accommodate this more?
The culture of experimentation has definitely changed. People thinking about putting their changes behind a flight has changed. Whereas before they would just push it, now they actually understand, let's do this incrementally and make sure we don't mess up the live side for everybody else. There is so much detail on our scorecards that it would stagger you. Even faculty, even academia, you'd be staggered by how many metrics we have available on a scorecard for Bing. So they highlight the ones with the highest confidence interval, right? And they make decisions based on that.
I was asking, how has your recruitment process changed to accommodate for people that think this way, that think in terms of experiments, as opposed to people that think in terms of code, perhaps?
I don't think recruiting has changed much. It's a learned experience, right? Like, we're hiring for their technical talent, and they learn flighting on the way.
But we had a big transition from testing to data scientists. I mean, in terms of HR, didn't we? I mean, in Microsoft, my understanding was like a lot of
folks who were doing testing, the testing discipline became more oriented toward data science, and actually we had job title changes and all that sort of thing happen. Yeah? I thought we went through a pretty big transition.
I can talk to that in terms of being on the experimentation team for Bing and for Office. The culture is hard, but let's put the hiring part aside. The culture change is very difficult. In Bing, that's the way they live and breathe. The engineers there know when the experimentation review is. They know how to go there. They know how to intelligently have a conversation about p-values and what statistics means. In Office, it's very much further away. One, the set of metrics is not as stable. It's not largely recognized across the organization that those set of metrics are important, and they are ship blocking or not. So we're working through that with Office and just educating both the IC engineers as well as the managers about how it works and why it's important. To Tom's point about data science, we have sets of data scientists with varying different backgrounds. There's testers that were turned into data scientists. I would say that some of their statistical knowledge is less than, say, a data scientist that we hired that has no computer science background but is a biology major, for example. And so there's varying degrees of statistical ability in that sense. Hiring-wise, though, as a developer, you need the skill sets of just being able to code in C++, build, be diligent, be able to go deep, understand architecture. The statistics part is important, but it isn't what we would necessarily hire for. Data savviness is probably something that we would look for or ask about.
And you know, not just developers, but also someone who I'd call a product owner. I mean, there is a definite shift there. You know, this is among the Summit companies where now there is a hypothesis. So you want this function, you know, you want this new feature. What's your hypothesis? What would change if you got that? And let's specify that as metrics. So that's like a whole different type of process. And sometimes product owners are technical people, but sometimes they're business oriented. But they have to have this new mindset to deal with experimentation.
You could even turn that question around and say, do you need experts in data science? Could your experimentation platform be made simple enough that anyone could understand it without a data science degree? That's what we aim for, right? Like anyone should be able to do an experiment in Bing. It's not always the case, but.
I'm just looking at the time, so the last question.
Yeah. More importantly, the data science reminds me very much statistics. There's no surprise that in schools you have biostatistics, you have physical statistics for physics, you have engineering statistics, so different discipline, because data depends on how you collect the data, what representation you make in the data, whether it's symbolic representation, whether it's numeric, whether it's any other representation, and then what questions you are going to ask, and that depends on the domain. So yes, computer scientists have a role there, but they just have, I don't want to put any number, but they just have a role. But it really is a discipline dependent what the data is going to be collected and what questions will you be asking.
Or product dependent, right? The products are different. MSN set of data scientists have a different product than Office does. And so you have to be able to ask the right questions. What does it mean in Office in terms of subscription users and enterprise users versus MSN, which is a primarily
and that must be a little challenge for
a
company like Microsoft that wants to sell a platform that covers a much broader audience. Nevertheless, You have to be realistic what to expect.
Yeah.
I think on that point, can we thank the speakers again? So thank you very much for coming.